Okay, imagine a battery that charges in 5 minutes, lasts for 100,000 cycles, and has an energy density so high an industry chairman called it impossible. That is the incredible promise of Donut Lab. But are these claims for real? Well, today we're diving into a huge piece of the puzzle, a brand new, independent, high-temperature test. So, did the data actually back up the hype? Let's find out.
To really get what's at stake here, you have to understand the skepticism. I mean, when Donut Lab first announced their battery, the reaction from the big, established players wasn't just doubt, it was total disbelief. This quote from Svolt's chairman says it all. They weren't just saying, oh, that's difficult. They were saying the laws of physics as they understood them made it flat out impossible.
And here's exactly why they were so shocked. These are the claims that just sent ripples through the entire industry. 400 watt-hours per kilogram, that's a massive leap forward. 100,000 cycles? I mean, that's a whole different league compared to the few thousand you get from today's best batteries. And on top of all that, 5-minute fast charging, and this incredibly wide, safe operating temperature range. It really sounds less like the next step and more like a total reinvention of the battery. So today, we're going to zoom in on that last claim, the temperature range, because, heat is pretty much the arch nemesis of battery technology. Pushing a battery to its thermal limits is how you reveal its true character. So what actually happens when a regular battery gets too hot? Well, think about the battery in your phone, or your laptop, or your EV. It basically lives in a thermal comfort zone. You push it much past 60 degrees Celsius, that's about 140 Fahrenheit, and really bad things start to happen. The internal chemistry starts breaking down, it ages way faster, and in the absolute worst-case scenario, you get what's called thermal runaway, and that is a dangerous self-sustaining fire. So when you put them side by side, the difference is just stark. Conventional tech hits a hard wall around 60 degrees. Donut Lab, on the other hand, claims stable operation all the way up to 100 degrees Celsius, literally the boiling point of water. We're not just talking about avoiding damage here, we're talking about stable, reliable performance in conditions that would absolutely destroy a normal battery. This isn't just an improvement, it's a whole new ballgame. But of course, claims are just words. To turn them into actual facts, Donut Lab needed independent proof. So they sent their battery over to a third-party lab for a really tough evaluation. And, the choice of who does the testing is just as important as the results themselves. The lab they chose is VTT, the Technical Research Center of Finland. Now, here's the crucial part. They are a government-owned, completely independent institution. Their job isn't to sell batteries, it's to run the tests, be impartial, and just report the data whatever it says. And that adds a serious layer of credibility to whatever they find. And here it is. This is the actual test setup. It might look simple, but it's incredibly precise. That silver pouch is the Donut Lab cell, and it's sitting inside a climate chamber. Now that heavy steel plate on top, that's not random. It's there to apply a gentle pressure to simulate what it would be like for that cell to be compressed inside a real-world battery pack. Okay, so the protocol VTT followed was really clean and methodical. First, they got a baseline capacity at a normal 20 degrees Celsius. Simple enough. Then, they cranked the heat up to 80 degrees, let the cell just sit there and soak in it for 2 hours, and then discharged it. Then they did it all over again, but this time at a blistering 100 degrees. Finally, they cooled everything back down to see if the cell even still worked. So they basically put this cell through temperatures that would kill a normal lithium-ion battery. The big question is, what happened? Did it survive? Did the performance totally degrade? Or did something else entirely happen? This is where it gets crazy. The result was not what anybody expected. At 80 degrees Celsius, the cell didn't just survive, it delivered 10.5% more capacity than it did at room temperature. Its performance actually got better in the heat. And it wasn't a fluke. Even at 100 degrees Celsius, the cell still delivered over 7% more capacity than its room temperature baseline. This is the complete and total opposite of how conventional batteries behave. Right, for anyone who wants to see the raw data, here it is, straight from the official VTT report. You can see the baseline at 20 degrees was 24.9 amp hours. At 80 degrees, that number jumped to 27.5. And even at 100 degrees, it was 27.6. The numbers don't lie. The cell not only handled the extreme heat, it actually seemed to thrive in it. So why? Why did this happen? Well, it all comes down to the fundamental difference between a liquid and a solid. In a regular battery, that liquid electrolyte is kind of like a highway that starts to melt and gets sticky in the heat, slowing everything down. But in this solid-state cell, the heat actually makes that highway smoother and wider, letting the energy flow more easily. That's why the performance went up, and it's exactly what this VTT data shows.
Okay, so this is a huge validation for Donut Labs' high-temperature claims, no question. But, and this is a really big but, it's important to remember this is just one piece of a much, much larger puzzle.
The test wasn't 100% perfect. In the report, VTT noted that after that 100-degree test, the cell's pouch had swollen up just a little bit, losing its vacuum seal. This suggests some gas was produced inside, what's called outgassing. Now, the cell still worked and it recharged fine, but this does raise some questions about what might happen over hundreds or thousands of cycles at these kinds of temperatures.
And that brings us right to what's still unproven. This test, it didn't measure energy density. That's the physically impossible claim. It didn't test the cycle life, that incredible 100,000 cycle promise. And it didn't look at cold performance or cost. And honestly, these are the biggest mountains Donut Labs still has left to climb.
Now, let's put all this in perspective for a second. The giants of the industry, we're talking Toyota, Samsung, KTL, they're all targeting 2027 or even later for their first solid-state cells. Donut Lab has claimed they will be shipping batteries in production motorcycles in the first quarter of 2026. I mean, that deadline isn't just ambitious, it's incredibly ambitious.
So, what's the verdict here? The VTT test has independently verified one of Donut Labs' most audacious claims. We now know this battery can thrive in extreme heat. But the most revolutionary promises, the ones that could genuinely change everything, are still out there, just on the horizon. The real question now is, can Donut Lab prove the rest?